Here we go. The recorder's on now. Here we go. We're going to talk about solving radicals today. So, what do we know about the domains of these two parent functions that are listed? Well, hopefully you're looking at the one on the left and thinking, okay, I know that the domain has to be from 0 to infinity because we cannot have any negatives under a radical. Those are imaginary solutions. Okay, the second one, the cube root, we graphed these on Friday, and hopefully you remember, well, you can take the cube root of negative, positives, or zeros. Therefore, the domain is from negative infinity to positive infinity. It has no restrictions on the domain. And now this concept is going to come back to us later as we're starting to solve radical equations. Okay, so how do we solve equations with radicals or even rational exponents? Now remember what rational exponent means. That just means it has a fraction in the exponent. Okay, if you guys remember, there are some rules. When you have the nth root of x to the n, that just equals to x. Or if you can also write that n on the outside of the radical. So it can be the nth root of x all raised to the nth power, and we know that those just cancel out and you end up with x. So in either form, those two are equivalent to each other. Okay, so how do we solve a radical equation? There are kind of 4 steps to solve these, and these are the 4 steps. So I'm going to get another color pen here. First, you want to isolate the radical. You want to get it by itself on one side of the equal sign. So you want to have this radical on one side. Then you want to look at the power. So if it's just a square root, then the nth power we're going to raise it to is 2. Or if it's a cube root, we'll raise it to the 3rd. So look at the nth power and raise both sides because it is an equation. So you have to raise both sides of the equation to that power. And then that gets rid of your radicals in most cases. We are going to have 1 or 2 that's not quite the same. But for the most part, you can now solve for the variable. And then, as always, you want to check your answer. Or sometimes it's answers, if there's more than one answer, to look for extraneous solutions. Now, this extraneous solutions concept goes back to the very first slide. Which one do you think would have extraneous solutions? A square root or a cube root? I am hoping you're thinking probably a square root because, yes, the radical square root equations do have limited domains. So you have to be careful and check for those extraneous solutions. So let's try one here. Okay, our first example. We want to isolate the radical. Well, this radical is already isolated. So all we have to do is raise both sides to the nth power. Well, since this is a square root, we're just going to square both sides. So square the left side, square the right side, and the square root just cancel, and you end up with x minus 2 is equal to 7 squared or 49, and then add your 2, and you get 51. So x is 51, and let's just check it to make sure. 51 minus 2 is 49, so the square root of 49 is indeed a positive 7. Okay, so that one checks out okay, so that solution is a good solution. Now let's look at the second one. We need to isolate the radical, so we need to subtract 9 from both sides, and that leaves us with 3 times the square root of x is equal to 6. So the square root of x is equal to 2, and then we get the radical by itself. So that it took us several steps to get step 2, to isolate the radical, which is actually step 1, sorry. And then step 2, let's square both sides, and we get x is equal to 4. And again, let's check our solution. So let's go back, plug it into the original equation. 3 times the square root of 4, that's going to give us 6, plus 9. Does that equal 15? Yes, indeed it does. So this is a good solution. So there are 2 very simple radical equations. Okay, let's look at a couple more. Let's look at this one, okay? So we've got the square root of 2x minus 1 is equal to negative 3. The radical's already isolated, so let's square both sides. And we're going to get x minus 2, or 2x minus 1 is equal to 9. Add your 1, so you get 2x is equal to 10. So x is 5. Now, let's check this one. When we go back and plug it in, we get the square root of 2 times 5 minus 1. Okay, that's 10 minus 1 is 9. So the square root of 9 is that negative 3. The answer is no, it is not. The square root of 9 is 3. Now, the square root, this is when it gets a little tricky. People say, well, when you square root both, when you have to take the square root, you get positive and negative solutions. Yes, that is true if you're starting with x squared equals 9. When you take the square root of both sides, you end up with x having two possible solutions of positive and negative 3. Okay, when you're taking the square root of an x squared, we have two possible answers, numbers we can square to get 9. But the square root of 9, this is a positive in front of that term. Therefore, we're only looking at the positive solution, so that one is not a solution. So if you want to check it, we checked it, it didn't work, so this one has no solution. Okay, so let's look at this one. This one's a little bit different. This one, we have a quadratic, so let's try this one. We have radicals on both sides also, so it's a little bit trickier. What we want to do is we can't isolate each radical because this is going to have a coefficient, but that's okay because what we're going to do is we're just going to square both sides. So we want to square the entire right side, and then you're going to end up with x squared plus 8 is equal to, and be very careful, this is going to be 4 times 2x minus 1, and then you'll get x squared plus 8 is equal to 8x minus 4. Now let's collect all our like terms. So we get x squared minus 8x plus 12 is equal to 0. So x, let's factor this trinomial, and we get x minus 6, x minus 2. And so our two solutions are 6 and 2. Now we need to check these and make sure they work. So let's see. Let's plug in the 6 first. So 6 squared plus 8. That's 36 plus 8, which is, what's that? 36 plus 8 is 44. So we're looking at the square root of 44, which is 2 root 11. And then let's plug a 6 in here, and we get 12 minus 1, which is 11. So we also have a 2 root 11. Okay, so it looks like 6 is going to check for us. It works. Now let's go back, clean this up, and now let's plug in our 2. Okay, let's plug in 2 this time. Okay, so we're going to plug in 2 squared is 4. So we're going to take the square root of 12, which we know is 2 root 3. And we'll plug in a 2 here. 2 times 2 is 4, minus 1 is 3. So we also have a 2 root 3. So these two check out, and they are equal. So this one actually has two solutions. And if you want to think, we're going to do this a little bit tomorrow, but if you want to put those in your graphing calculator, you can actually see that those two radical equations intersect each other twice. And you can find the intersection point. So you might want to go back and play around with that. Okay, now, what happens if we have a 4th degree? Okay, so we isolate the radical as we do the other ones. So the radical is isolated, but this time we're going to raise it to the nth power, which this time the nth power is the fourth power. So let's raise both sides to the fourth. That leaves us with x minus 1 is equal to 2 times 2 is 4 times 2 is 8 times 2 is 16. So x is equal to 17. So let's check it by plugging it back in. And the fourth root of 17 minus 1 is the fourth root of 16. And the fourth root of 16 is indeed 2. So that 17 checks out as a good answer. Now let's look at one with a fifth root. And this one actually has radicals on both sides. So we've got a fifth root. So we're going to raise both sides to the fifth power. Okay, notice I'm showing that step. So you want to show that step. So you get x minus 1 is equal to 3x minus 8. Collect your like terms. So 7 is equal to 2x. So x is equal to 7 halves. Okay, and then we can plug that in. 7 halves minus 1, which is 2 over 2. That equals 5 halves. So we're taking the fifth root of 5 halves. And let's see what the other side is. Let's plug into this side. Plug in 7 halves. So 3 times 7 halves minus 8. That's 21 halves. So that's minus 16 halves, which leaves us with 5 halves. And that's all under a fifth root. And notice these two are equal. Whoops. My pen got a little out of control there. They're equal. Therefore, that is a good solution. So 7 halves is a solution. Okay. So here is a little extra tricky one. Okay. What we want to do is we want to isolate our radical, which we have done already. So now we're going to square both sides. But what's a little bit tricky about this one is, what are we going to have to do to this left side? We're going to have to FOIL it out. We're going to have to multiply that out to x squared minus 8x plus 16. And that is all equal to 2x. So let's bring the 2x over. So we get x squared minus 10x plus 16 is equal to 0. So let's try to factor this. What multiplies to 16 but adds to 10? And we know the answer is a negative 2 and a negative 8. So our two solutions are going to be positive 8 and positive 2. Now, we need to go back and check these and make sure these both work. So let's plug in 8. 8 minus 4, is that equal to the same thing as 2 times 8? So that's going to give us 4 is equal to the square root of 16, which is indeed 4. So that one looks good. And let's plug in a 2. 2 minus 4, is that equal to the square root of 2 times 2? Well, this one's going to be negative 2, and this one is the square root of 4, and that's not a good solution. So this one only has one solution, and that's where x is 8, and 2 is considered an extraneous solution. Okay, so that's how we do radicals. Now let's look at it in the form of rational exponents. And rational exponent just means it's a fractional exponent. So what we want to do is kind of walk through these steps. We want to isolate the power. That's the term with the power. We want to raise to the nth power so that x, or whatever is being raised to that power, is to the first power. And then we want to solve. So let's look at the first one. What we want to do, we've got x to the 1/2 power, and we know 1/2 is really just the square root written as a rational. Okay, we want x to be to the first power. So we need to raise it to the reciprocal of 1/2, which is 2 over 1, or just squared. So we're going to square the 10, and we get x to the first, right? Because when we multiply a half times 2, we're just getting 1, is equal to 100. And let's check it. Is 100 to the 1/2 power equal to 10? And that is true. 10 to the 1/2 is 100, so that one checks out. So our answer is 100. Okay, so let's look at one that's a little more involved. Okay, so we've got 2x to the 3/2 minus 1. We want to isolate this term right here. So we're going to add 1 to both sides, and we're going to get 250. So 2x to the 3/2 is equal to 250. And then, of course, we're going to divide by 2. So we're going to get x to the 3/2 is equal to 125. Now, this time, we've got to raise both sides to what power? Well, in order to get x to the first power, I need to raise this to the 2/3 power. Raise to the 2/3 power. So this becomes x is 6 to the 6, or just 1. And then the right side, I get 125 to the 2/3. So let's think about what the 2/3 power means. That means I'm taking the cube root and then I'm squaring it. Okay, so if we need to, we can rewrite it as a radical. So remember, this is the cube root of 125. And we're taking that answer and we're squaring it. So cube root of 125 is, if you can do a factor tree, but you probably need to know those. We've talked about that. You need to have those memorized. And that is 5, and 5 squared is 25. So there is our answer, 25. Now let's go back and check it. Let's plug this in. So we have 2 times 25, this time to the 3/2, all minus 1. So 25 to the 3/2 means I'm going to take the square root of 25, which is 5, and then I'm going to cube it. So that's going to give me 5 cubed, which is 125. So 2 times 125 is 250, and then 250 minus 1 is indeed 249. So guess what? We have a good answer. So that means 25 is the solution to this one. Okay, let's look at this third one down here. Okay, we have x minus 1 all raised to the 2/5. If you guys want to work ahead, you know you're going to raise this to the 5/2. And then we've got to raise 16, the other side, also to the 5/2. Okay, we know that these are going to cancel out and just give us the power of 1. So we have x minus 1 is equal to, well, we're going to take the square root, right, of 16, and that's 4. And then 4 to the 5th power. Let's see, what is 4 to the 5th? I don't know that off the top of my head. Let's open this up and do that. 4 to the 5th power is 1,024. I should know that, but I don't. Okay, so 1,024. Then we're going to add 1 to solve for x, and x is 1,025. And again, you can take that answer, plug it back in, take 1,025 minus 1. That's 1,024. You're going to take 1,024 and raise it this time to the 2/5 power. That means I'm taking the 5th root of that, and then I'm squaring it. Well, we know the 5th root is 4, and 4 squared is 16. So that ends up checking out. So x is equal to 1,025. Okay, so let's look at a couple of these. I picked this one to show you guys because when you go to square this, what do we need to make sure we do? We want to make sure we square the right side, but we also want to make sure we square the left side, and we got to square this too. So that's going to give us 4x squared is equal to 4x plus 8. And I hope you know what to do with a quadratic by now. We get it in descending order. And equal to 0, because we need to do what? We need to factor it. Divide everything by 4, so we get x squared minus x minus 2 equals 0. And then what multiplies to negative 2 and adds to negative 1? X minus 2 times x plus 1. So our two solutions are going to be a positive 2 and a negative 1. But as always, especially since we've got a square root, we need to check our answers. So let's plug in 2. So let's see, the left side will give us 4. And then plug in a 2 on the right side. And we're going to get 8 plus 8, which is 16. That is not a good solution. So let's check the negative 1. Negative 1. So we got negative 2 on the left side. And then on the right side, whoops, I forgot to take the square root of this one. Sorry, that answer is 4, and that answer is good. Whoops. That is a good solution. Let's try the negative 1. Sorry, I forgot to take that negative square root. Our square root is 16. Now let's plug in this negative. So we have negative 4 plus 8, which we know is the square root of 4. Is the square root of 4 negative 2? No. So this one has one solution, and that solution is x is equal to 2. There we go. Okay, so what have we got left? Just a couple that I want to show you that can tend to be a little bit trickier. So this one right here is a good one to look at. Okay, what we're going to do is we're going to have to square both sides. And when we square both sides, notice we're going to have to FOIL this right side out. So I'm going to get negative 9x plus 28 is equal to, and that's going to give us an x squared minus an 8x plus 16. And then we've got a quadratic, so let's get them all in descending order. It's going to be x squared plus x, and then what's that, minus 12 is equal to 0. So we're going to factor that one into x plus 4x minus 3. So our solutions are negative 4 and positive 3. So since these are square roots especially, let's make sure both of these work. So let's plug in the negative 4 first. So negative 9 times negative 4, that's going to give me positive 36 plus 28. That's going to give me what? 464. Square root of 64. See, I remembered to do the square root this time. And let's take the right side. I've got the negative of negative 4 plus 4. And that's going to give me 8, right? And so that one is true. The negative one works this time. Let's see if the positive one works. So negative 9 times 3 plus 28. Okay, we're going to take the square root of all that, and that's negative 27 plus 28. That's the square root of 1. Let's go over here and take see if it's equal to negative of 3 plus 4, which is equal to 1. So the square root of 1 is 1, and so that one too is a good solution. So this one has two solutions, negative 4 and positive 3. Okay, this one is our last one, I believe. Let's check. Nope, two more. This one is just a little bit trickier because there are a few more things to do. On this one, we need to isolate what's being raised to the power. So we want to divide by 3 first. So we're going to get x plus 3 to the 3/4 is equal to 27. And now we're going to raise both sides to that 4/3 power, to the reciprocal power. And let's see what that gives us. That gives us on the left side x plus 3. And on the right side, we're going to take the cube root of 27. And we're going to take that cube root and raise it to the 4th power, which is 81. So if x plus 3 is equal to 81, that means x must be equal to 78. Now let's check that and see if it works. 3 times 78 plus 3 to the 3/4 power. Let's see. This gives us 81. So 81 to the 3/4 power. So we need to take the 4th root of 81, which is 3, and then we're going to cube it. So the 4th root of 81 is 3, and then 3 cubed is 27, and then 27 times 3 is 81. So is 81 equal to 81? And the answer is yes. So that is a good solution. Okay, so that one you had to isolate the radical for, or isolate the term being raised to the exponent of 3/4. And this last one. This problem, I thought it was kind of cute. This little problem is a bird of a different color. It's a tougher one. Okay, we've got radicals on both sides, and we have a constant that's not under the radical. So yes, we've got one of the radicals isolated, so let's go ahead and square that one. Well, if we square that side, we have to square this side. Well, the right side's pretty easy. We're just going to get 9x. But the left side, we're going to have to FOIL this out. So the square root of x times the square root of x is just x. And then we FOIL outer and inner. We get -8 root x. And then plus 16. Okay? So now we still have a radical in it. What do we need to do? We need to do it a second time. We need to isolate the radical a second time. So let's collect our like terms. Let's take this x to the other side. And that's going to give us, oops, sorry about that. That's going to give us -8 square root x is equal to 8x minus 16. And now we need to continue to isolate this square root, so let's divide by -8. When we divide by -8, we're going to get the square root of x is equal to -x plus 2. Now we've got the square root isolated, so now we square a second time. So this one took two times to square it. We get x is equal to x squared minus 4x plus 4. Now we're going to bring that x over to the other side, so we have it equal to 0. So we're going to bring the x over, and that's going to make it -5x and positive 4. So what multiplies to 4 but adds to -5? And we know the answer to that. That's going to factor into x minus 4 and x minus 1. So this one's going to have two potential solutions. So our answer is 4 or 1. Now let's go check out and see if either of those work. Well, if I plug in a 4, I get 4 square root of 4 minus 4. Is that equal to the square root of 9 times 4? So that's going to give me 2 minus 4, which is -2. Is that equal to square root of 36? The answer is no on that one. So 4 is not a solution. Let's try 1. Okay, the square root of 1 is 1. And 1 minus 4 is negative 3. Is that the square root of 9 times 1? Or square root of 9? No. So guess what? This one, all that work. And this one has no solutions. Ooh, that's a lot of work for no solutions. It can't be either 4 or negative, or 4 or 1. Okay, at this point, we're going to stop here, and you guys are going to complete the classwork I left you. There are 15, 16 problems, I believe, and you're going to turn that in. Have a great night, and then you guys know your homework. It's on your calendar, and it's on solving radical equations. Hope this was a helpful video, and I will see you tomorrow.